It's show time. Awesome. Hi, everyone. Good evening, good morning, good afternoon to whichever part of the world you're joining from. Super happy to see you here. If you can hear me, please let me know. I'll just check across platforms meanwhile that we are live comfortably for anyone and everyone who has joined in. Okay, so if you're watching us on whichever platform joining us with, so where are we joining from? Okay, please drop in the comments. And we'll get to know that you can see us perfectly. Meanwhile, I'll also check from my end. Hmm. Oh, Akshar says we can hear you. Thank you, Akshar, for confirming. Awesome. Folks on LinkedIn, I'm not sure. So this tool that we use, it doesn't give us stats for LinkedIn. So if you can hear me, I'll also check on LinkedIn, by the way. I'll just go to the event page and check if you're live there. Folks can hear us. Awesome. There are 11 people as of now, I think, on LinkedIn. More people will be joining in. But yeah, okay, great. Awesome. Great. So I'll just wait for a minute or so. Also, people who are joining from LinkedIn, right? They can drop in the comments. I'm not sure how many of you know about it. So let me just, do a quick intro of DeFi for those who are joining for the first time, because we see that in every live session that we do, we have a set of mix of both, new attendees and our old community members who have been with us for a long time. So first off, I'm Mudit. I'm one of the founding members of DeFi. We are a global community of AI enthusiasts. In terms of numbers, we're a 100K plus strong community from 140 plus countries. But the most important thing about our community is that it's purely volunteer driven, and every single resource on our platform is 100% free. So for example, if you visit this particular session, right, you're watching this. So it's 100% free. Similar to this, we keep on conducting boot camps. We conduct live sessions. We conduct courses. There are over 30 courses on our platform, which can be accessed anytime you want to. Okay, so I'll probably give a gist about. Do we have a Slack channel or a discussion forum? Yes, I'm glad you asked, Ayush. We have a Discord server. I'll share a link for it towards the end, or maybe I'll drop it, yeah, towards the end so that people can focus more on the live session. I'm new to machine learning for community. Awesome. Yeah, yeah, we have a lot of beginners, by the way, so that is perfect. Okay. But yeah, I'll probably share about DeFi quickly. So these are the courses. If you go to DeFi.tech backslash live sessions is where you can see these sessions happening. On courses, you will find these 35, 20 plus, 25 plus courses, okay, published. In the challenges, you will see AI challenges happening. Most of them have real world data sets, so that way you can get your hands on skills brushed. Boot camps is one where it's more of a cohort based learning. You'll have to complete assignments. There'll be live sessions also as a part of it. It will be an intensive but a superb learning experience from point A to point Z. And then we have these live sessions. Okay, you can also learn from others notebooks and all. And we conduct these live sessions on a weekly basis. Every week we have these sessions. Okay, for example, as we're speaking, we have this particular session. Next week itself, we have another session with Databuzz. Now, as I'm mentioning Databuzz, I want to quickly talk about it, and I'll be looping my co-host for today's date, a very special co-host. So a lot of you who have been with us might have seen her in the past. She's Supreet Kaur. She's the assistant vice president at Morgan Stanley US, and she's also the founder of Databuzz. Now, what Databuzz is, what it does, I'm sure I can do that, but Supreet will do it 10x better than me. So let me just quickly loop her in. So yeah, hi Supreet, how are you? Good to see you here.
Hey, Mudit. Thank you for that introduction. So, hi everyone. As Mudit mentioned, you must know me, or you can at least find my session on the DPhi website. So, I'm Supreet, and I founded this community. Similar goals as DPhi. It's completely volunteer-driven community to engage all the tech enthusiasts, AI enthusiasts on the latest tech trends. And I personally provide them one-on-one mentorship. I provide networking opportunities. We have a huge base here for international students who want to contribute to the community. So I do connect them with my friends, with my coworkers, and we provide mentorship on job search, how to get your first internship in US, how to pivot in this field with a non-tech background. And now we have taken this community one step ahead and kind of partnered with DPhi, and we'll be hosting this amazing AI series. This one is the first session under that partnership, but we have some very exciting speakers lined up in the coming weeks. So you all should stay tuned. Follow DPhi, follow Databuzz for more such content. And I'm super excited for this first session, and I hope it will be a success. So thank you all of you for joining. Please be active. Please ask a lot of questions, and I'm sure you'll benefit as much as I will today.
Yeah, and actually the community has been excited even for this session. And yeah, I think probably we can jump right into the session, and probably you can
Yes.
introduce who's with us today to talk about a
Yes.
very rather interesting topic.
Yes, yes, exactly. So I think Janani and me, we go long back. So in 2017, when I came in US, I joined the program. She joined, I think 6 or 7 months after I joined the program, but we had some courses which we were taking together, and we kind of had an overlap. Uh, I don't think we ever did a group project together, like you normally do in US, but we somehow clicked and we started talking. And she is an amazing person, very hardworking. So I think somehow we continued that bond, though we graduated 3 years back. And right now she's data analyst at Integral Life Sciences. She'll definitely talk more about herself, about her work, and about the topic today. But this is a very close friend that I'm presenting today. So Janani, welcome.
Yeah, so we have Janani with us. Hi, Janani.
Hello everyone. Hi, I'm Jhanani Ramesh, and as Supreet said, we did our course together. It was the Master of Business and Science at Rutgers University, and we majored in data analytics. So right currently, I'm working as data analyst at Integral Life Sciences Corporation, and we do a lot of exciting stuff with machine learning and all that, and also all types of analytics. So today, jumping right into the content, like today is about the ensemble methods, and I'm going to share my screen.
Awesome.
Sure. So we'll probably go to the background
Yeah.
and dive right into the session. Also, I've dropped the registration link for Databuzz and Discord community of DPhi. I would really request if you go to it eventually. Let's learn here, and then we'll be sharing these links again for you to have a look at. Okay. I'll also drop an
Great.
email to everyone who has registered. So yeah. Uh,
Can you see my screen?
yes. Yes. Yes.
Yep. Okay. So today's topic is ensemble methods, and so what does ensemble mean? It's just that we are putting like different parts together and then making it a whole. That is what the dictionary, the literary meaning of the word says. But in machine learning or AI, what it means is like we put all different models together and then we try to reduce the bias or the variance. So we get a strong learner. It is overall going to improve our performance. How and what are those is what we'll see today. So there we could say ensemble is like, okay, what are the basic ways of doing it? You have max voting. It's like just each model gives you an output saying yes or no, and if whatever comes majority, that is called as max voting, and then that is used for classification models. For all the non-tech audience, classification would be a model or problem is where you say yes or no, whereas regression is like a continuous number, you'll be predicting a number. So for ensemble methods, it's like you for the same data set you apply different models, and then how do you select what is the right answer? It's like for classification it's max voting, saying which is the best model just by taking vote. It is possible by using the voting classifier library in Python. And averaging is like just taking an average of each of the model's predictions, and that would be your result. And then we have weighted average, which is again mostly used for regression problems, where you give weightage more to one model over the other. We can think of it like you ask for feedback about a movie to your friend or your colleagues and all that, but then you want to give more weightage to the critics of the movie. So that, and then you take an average. So it's like that is weighted average. So these are like simple things which we can do, but what happens with advanced ensemble techniques? So that we have three major categories there. One is bagging, then boosting, and then stacking. So we will go into each of that conceptually, and then we look into stacking in a code-wise and a workflow also, and we will look into that today. So bagging. Bagging is you take a data set, you take a original data set, that is a full data set, and then we divide that data set into subgroups or subsets. And each subset can have those data points with replacement. So when I say that, if let's say the original data set had 1, 2, 3, 4, 5, it can have 1, 2, 1, 3, 1, 4, 1, 5, 2, 1. So it's like there's a replacement. So it's a data set with replacement, and for each subset of data, a separate model is applied. Again, for each subset of D2 data, a separate model 2 is applied. And we get the results and the predictions of this. And here we do any kind of averaging or max voting or things like that to get the combined prediction. So there are models that already do the entire thing, like that one probably, which most of us know, is the random forest, where each model is a decision tree. That's why, like, group of trees, they form forest. So decision trees, group of decision trees forms a random forest. And so this is a tree, this could be another tree, and all this together would form the random forest. And that is an example of bagging also. There's another example or another algorithm that is like bagging meta classifier, or like meta regression, like whatever you use, that is also using similar things where you don't select the models, the algorithm selects the models and also plays with the hyperparameters and all that. So that is for bagging. So boosting is another ensemble method. Here, what would happen is, again, we take the subsets, but this is more like a sequential rather than parallel. So you take a subset of the data. So let's take the whatever's colored orange in, with background. We would take that subset of data, and then we create the model, train the model, and then we would predict the model for all the data points, giving equal weightage to it. And then we see, okay, what are the data points that were predicted with error? And those data points, for example, these three plus, you see those were predicted incorrectly. So this time we will give more weightage to those incorrectly predicted ones than the others. So the step again continues. We'll take a subset of this data set, train the model, and then predict for everything else. Whatever is incorrectly predicted will be given weightage to the next step, and again we do it. We do the same kind of training, and then we predict. So this keeps adding on until we get the final model. So the final model aims to be the strongest learner because each of the models have given higher weightage in learning those errors. So all those, this model might, for the first model, might be a good model except for these three data points. So it's a weak learner for these three, but that has been compensated in this model where it gives higher weightage and learns. Therefore, a set of weak learners, but then they form the strongest learner. So that is boosting. It's more like in a sequential way. This is another chart of boosting. So again, it's the model here. Whatever is incorrectly predicted, we give higher weightage. So those are the weaknesses. And with, it's like weightage to the weakness, and then we train the next model. It keeps happening, and then at last you get the final model, which is said to be the strongest learner. Overall, bagging and boosting is, bagging is more like parallel, whereas boosting, it goes like, okay, what is a weak here, it becomes a strong in next. Whatever is a weak here becomes a strong in the next one. So this is more like parallel, and this is more like a sequential methodology. And this is what happens conceptually behind bagging and boosting. There are already libraries and algorithms out there which have been developed based on these methodologies, and those would be these. So we have like bagging meta estimator and random forest decision tree. Those all are like bagging examples. Databuzz, XGBoost, gradient boost, all that would be like boosting examples. We also have this, and there are hyperparameters. If you look into the libraries, you could see that there are a lot of hyperparameters where we can tune them. So not just taking a default, but there's also this opportunity for tuning them to better suit our models and get better results. So that is it. And now stacking. So we said three models: bagging, boosting, and stacking. Bagging is more like parallel, boosting is like taking it sequentially, and then we have stacking. So here in stacking, we we take the training data set, and then we apply different models. Let's take a classification example which says yes and no as the final result. So we'll take a different, or like let's take a regression where you predict what is the temperature of the day, so something like that, and then you get different values as C1, C2, C3. These are models, and these are its corresponding predictions. So these predictions will act as the input to the meta classifier, which is also an algorithm. This is similar to boosting, but a bit different. Why? Is because boosting we just do like max average or something at the end, but here we add another layer of models. So this becomes this level 0, this entire C1 and P1. C1 is the model and P1 is the prediction. So like C1 classifier 1 and P1 is the prediction. So these becomes level 0, and this is level 1, the next level. If needed, we can actually add as many layers as we want. Then it becomes like a neural network, going into the AI part. But then with a simple structure, we'll just keep two levels, level 0 and level 1, and we have this layer, which each of them would work on the training data set and give an output, and those predictions are given as input to the meta classifier, or which is like another data model, and we get the final predictions. So when the testing data or the valid goes, it just goes, and then it goes into the model, and they are predicted, and those predictions becomes the input there. Excuse me. So there is another layer, or like a bit of modification which can be done, where that's called as blending, uh, where you would train the meta classifier with the data set only with the validation. If we do that, then it is called blending, which is like a bit of modified version of stacking, but overall this is what is stacking. And another visual would say it's training data set, you get different models, you do the predictions, and those predictions become the input to the next layer of models. And then we get the final predictions. This is with level 2 levels, but then we can add as many levels as we want. So why do we use and when do we use bagging, boosting, stacking? We see so many. When do we use? So bagging is majorly used when you want to reduce the variance, standard deviation and all that. But boosting is used to produce a strong model with lesser bias, because as I said previously, the weak learners would become a group of weak learners are going to form a strong learner. So boosting and stacking will be aimed to produce less bias and also less variance. So that is the purpose of why we would use. We could also say it's like a group of people coming together to do one project rather than one person doing it. So the overall performance is usually higher than just a single model. And now I will quickly go over an example using code of the stacking algorithm. So in this code, we'll first look at the data. As all we do, we always look at the data investigation, which followed by one of the most major steps, the exploratory data analysis, which I will not be concentrating today, where you do univariate, bivariate, multivariate, see if there are any null values, see if anything is correlated. If they're linearly correlated, should we remove things? Those are where the data prep, a lot of major time and effort must be spent to get extract insights, and that is data investigation. We'll do the basics of data investigation, and then we'll do data transformations where we do all the encoding. In this example, we'll be using one hot encoding. What is one hot encoding is when each of the values in a given column would become the headers. So it's like you might have a column as month, and then but when you do the one hot encoding, those would become like Jan, Feb as a column headers, and we'll see the example in the workbook. Yep, that is happening, and then we'll apply different models, a lot of data, different data models, and then that would be decision tree, bagging, boosting, decision tree, bagging, random forest, Databuzz, gradient boost, and XGBoost. So some of the models we can apply as many models, and then we will compare the model performance. So this is a data set, the most classic example Uh, the most classic example of the bank marketing data set, which is quite common in Kaggle or anywhere in the data science community. So here we take, these are the attributes that are there. You have age, the job, we have admin, blue collar, entrepreneur, housemaid, management, retired, self-employed. You have set of jobs, marital status, education, and then if default has a credit in default, housing, is there a housing loan, yes or no, loan, any other personal loans, contact type, month, campaign. P days is number of days that has passed between the client that was last contacted from the previous campaign. And these are like a lot of index values. And P outcome is previously if they were given some marketing campaign, did they make use of it? So what we will be predicting is, will the client subscribe to a term deposit? So will they do it or not with all these kind of marketing attributes? So the prediction is going to be yes or no, which is a typical classification problem. So we'll take a classification problem today to go over. In the first step, we have a lot of libraries. As usual, as we all know, we would call all our libraries, import them. I've imported the pandas, and then for visualization purpose, and these are the models that we have been using. I'm taking all from the sklearn library. And then the metrics, the confusion, accuracy, precision, recall, and F1 score. So precision is useful when we want to give more weightage to true positives, but recall is good when we want to have a lesser number with false negatives. And but F1 score overall is like we want to make sure we don't lose, like we should not lose people. Like our marketing should go to everybody, so that is also there, but then we should not waste our marketing efforts on the wrong people. So both are important to us. With that in mind, we will choose F score as the one we might want to give higher importance in metrics terms. So data investigation is like we read the data, and then we make a copy of it, and just so that we don't make mess up with the data. Take a look at the head part, and then taking a look at the tail part, and then we see there are like 11,000 records, 11,161 records with 17 columns. And those columns, there are no null values, no empty values, so nothing to do with how we would, there's no missing values, I would say. And then just seeing a simple correlation to see if anything, two things are linearly correlated. If so, should we remove them or things like that. And when I looked at the data, they were like nothing really that strongly correlated, so it's fine there. And so that gives a data investigation, but we could still do univariate, doing by column wise, by column. Can we do any other analysis? How is it distributed? We could gain insight. We will gain insights using EDA, but for this today's topic, for the Ensemble, we'll look into the transformation and then the models itself. So next we have data transformation part, where to deposit is a yes or no answer. We would want to convert all the yes and no into numerical value, 1 and 0. Here I have taken yes as 1 and no as 0. And all those other attributes, I'm going to encode it using one hot encoding, which is like get dummies in Python code. And we could see that by doing so, for example, under job, it was one, it was one column, but now it has become like job as blue collar, entrepreneur. So each of them, each of the values have become a separate column header, which is what one hot encoding does. And we have done that so that we'll be able to predict, and then splitting it into testing and training data sets. Overall, does the percentage of classes in training and test, does it look good? Yep, we have done 52% yes, 47% no in training, and 52% yes in testing, and 47% no in training. So yes, we have made a training and testing data set is like a mirror version of training data set. So it looks good. And now these are two functions to find the metrics and confusion matrix. So these are like functions which we will be calling from our models. As I mentioned previously, these models are embedded. I have written there's code for these models for them to be predicted. And now is the decision tree. For all these models, just the random state one is used. I have not played with the hyperparameters where we can do tuning and then we can tune our model. And even a default model can be model one, and a tuned hyperparameter model can be a model two of the same decision tree. So you can have as many models as possible. So we have the decision tree model that is called, and on training data set, so the dot fit is where we train the data. Sorry, we train the model using the data. And to see the metrics of training data, it looks great with all 100%. But then at testing, if we look at it, yep, it isn't as great as that. It's still 70%. So it's like the decision tree. A bagging classifier, it is going to be a algorithm based on bagging concept, where it does take subsets of data parallelly, and then it does those models, and then it happens parallelly. So that is a bagging classifier. And here again, I have not added any kind of hyperparameters. It's just a default one, and we have trained it. And then again for training, it's 99%, or like with F1, and testing is not bad, 82%. It's better than decision tree. Again, random forest. So here in all these models, I'm just going to call the model and then see its metrics for training and testing data set. And it goes on. Again, testing, Databuzz classifier, the gradient boost, and then X3 boost, a set of models. And then, so here comes stacking. So these are all algorithms which I'm just calling from the library and then using the metrics and to see what they're performing. We will compare the models at the end to see. It would be difficult for us to go over every data point or every metric or every percentage. We'll look at it at the end. So the stacking classifier. So as mentioned, the stacking classifier, you see there are 3 different models, and then you use a meta classifier which is trained on the predictions. So I have taken Databuzz, gradient boosting, and random forest as those level 0 classifiers. These are level 0 classifiers. So these level 0 classifiers are taken, and these predictions would be given to XGBoost classifier. And the model is trained on the predictions of these. So this is the stacking classifier. I'm calling the stacking classifier, giving the estimators as these level 0 models and final estimator as level 1 model. And this is how stacking happens. We train that model. Dot fit, we train the model, and then we are seeing the same kind of results for confusion matrix and the accuracy, recall, precision, and F1 for training and testing. So in the end, we will compare the models, see how they have performed. And I've just taken every model, their performance. If you see here, every model's performance, I'm putting it in a separate name, and then I'm calling that name, taking a transpose, so it becomes a data frame with this kind of structure. And this is the training performance. With that, we could see for training, yeah, decision tree is like 100%, but we could see that these are like 96, or the stacking, since we used a lot more models, XGBoost is also doing really relatively well, but stacking classifier seems to be better than individual models. Or let's go to testing, might look better. So this is a testing. For testing, yeah, the decision tree has fallen, but then at the stacking classifier, we could see for F1 score majorly, this is with 84%, and we have XGBoost also 84. So stacking is on one of the top 3, I would say, as models. So this is where we use, these are some of the ways of having different bagging and boosting. Decision tree, random forest, we can also have SVM and KNN, and then all different models, whatever we would like, and then take 3 models from it, like top 3 performance, put it as level 0, and then take one more model and put it as level 1 model to do the stacking and compare, and whichever model gives the best metric or best score for the desired metric based on our problem, we can use that and train it and keep that is a model that is ready for production. So that is about ensemble methods. So is there anything that is all I would want to cover today? Is there any, Supreet, is there anything that has come up in chat or something?
Awesome. I think, Mudit, for some reason, I'm not able to see the questions. I'm not sure if you
Oh, is
are.
it?
Yes,
Okay.
my private chat
Okay.
is blank. Oh, I had
Uh,
some comments. Oh, okay, okay. Now I can
yeah.
see.
Yeah.
Awesome. Do you want to get started? I think, yeah.
No, Supreet, you can take it forward. Actually, I'll
Okay,
also.
awesome.
Yeah.
Awesome. Okay. So I think there is one question which actually I also had. Is Bella asked when to use boosting and when to use stacking. Jenny, is it possible for you to maybe back that up with kind of a use case that you have in mind or something?
Boosting and stacking. So, well, boosting and stacking, I would use boosting as a first step to do different types of algorithm, all this Databuzz. But then I would use stacking to stack those boosted models and then put it and see how it works. In general, it either it matches the same value, or else sometimes the stacking is kind of better. Um, it is both of them reduces the bias. Both the aims reduce bias and variance. If we compare it with bagging, yes, bagging does not aim at reducing bias, but boosting and stacking both aim to reduce bias. And so do the boost I would do the boosted models first, and then I would take those boosted models and stack them and see if that makes sense.
Okay, got it. So
So I
stacking
would,
can be kind of considered a step two once you
step
have
two,
done
yeah,
the boosting.
yeah, yep, I
Yes.
would do that.
Okay. Okay, got it. Awesome. Um, and okay, I have a question. I don't see any other question, but I have a question. So as I was talking about use case, right? Like in industry, how do you see like stacking being used? Because like for the limited career that I have had, everyone talks about bagging or boosting, but no one really talks about stacking. So do you have any use case in mind that we can use?
Everywhere I would say that we are able to use bagging and boosting. We can also use stacking. Uh,
Hmm.
it isn't going to. Sometimes if the data is too huge, or you have like more. Right now we just discussed two levels of stacking.
Hmm.
If we have more levels of stacking, if we have too many layers of stacking, becomes AI. Neurons.
Yeah.
It
Yeah.
adds value, weightage. So it becomes AI. So
Mhm.
um, I would suggest if it's with just two layers, we should always try after bagging and boosting. We should try stacking also. Uh,
Hmm.
it will if it should not take too much of compute time either. So
Hmm.
it is use case any kind of class. So this stacking and or stacking and boosting is not specific for classification problems. We
Hmm.
can do it for regression. So
Exactly.
Databuzz classifier would be Databuzz regress or something like that.
Hmm.
So each mod boosting has classification and regression parts. Whichever is applicable, we should choose a required library and required model from the library and try for classification and regression. Stacking isn't that used, I would say, because the boosting performance are usually quite high.
Yeah. Yeah.
So it is getting where we want to go.
Hmm.
Therefore, maybe we don't want to spend time, extra time on stacking. But
Stacking. Right.
if you
Right.
have time and the compute energy, the power to compute it, try stacking also is what I would say.
Nice. So if we are saying that boosting kind of already gives us a good result, a good accuracy, metrics look good. If we do stacking on top of it, does our model become more prone to overfitting then?
It shouldn't become prone to overfitting, because the aim of this is to reduce the bias. So
Hmm.
it
Hmm.
shouldn't be overfitting. Um, if we feel it is overfitting, then we can use this other technique of blending, where
Hmm.
I was saying you train those level 0 models with the training data. But then
Right.
those level 1 models are not trained with the training data. It's only trained with the validation set.
Got it.
So the
Okay.
chances of overfitting drops drastically there. So
Right.
is
Right.
another hybrid version of stacking, or we can say a separate version as blending, where the level 1 and the final ones are not trained with the entire data set, but only with the validation sets. That would
Hmm.
reduce the overfitting.
Yeah. Yeah. That makes sense. Mudhu, do you see any other question that I don't see? This is all from my side.
No, no. I have one question. Okay, there is so generally on in production, do you see any common use cases of these three techniques? Bagging, boosting, and stacking.
In industry or in any company, like wherever you use classification, it depends on the industry where we work. Sometimes it's just marketing, will this make sense or not, yes or no. And then sometimes you have to predict something. Any use case a company uses, you predict sales, or you predict mm, any classification or regression for that matter. The other data set which I'm thinking, that manufacturer of automobiles or something, even that is like, I've, it's a sample data set which, like, we have MPG and all those as columns, like, any use case, because use cases way depend on the industry itself.
Right.
So it is more
Yeah.
with, I usually relate it more with the classification and regression category rather than use case. With sales predictions, yeah, we can predict sales. That is, you can also use time series models. So it does. So it depends. It depends on what attributes you have. For time series, you don't really need so many. You just need the date and the value. For this, you would need, so if you have many things where you would use to predict something, then I would say give it a try.
So is EDA the step where we get to understand which of these do we have to pick? I mean, between time series and the ones that you mentioned right now.
Yes, I would say EDA, but time series is kind of good when with anything related with time. I have always felt with anything that is related with time series works far better than regression. But EDA helps us to do feature engineering and feature selection. If in the correlation table, if we had seen any two things that are highly correlated or like linear, then it is necessary that we remove one of them. That was specifically linearly correlated with our um, final predicting column, then it is necessary to remove it. So
Okay.
Okay.
There are a few questions. So, Preeti, you want to pick them?
Sure. Yeah, so Bella has another great question. Are there any limitations of these advanced ensemble techniques?
I don't think so. It's just if you add too many, it is your computing power. Sometimes I feel
Yeah.
if you add too many layers, your local computers are not going to support it. If we have
Hmm.
two huge data sets, and then we took only three classifiers, if you take like 10 classifiers, have three layers, and then huge data set, the local computing system is not going to support, and it might take hours and hours of running. But then if you say
Yeah.
I'm going to use Azure or like cloud systems and then do it, yeah, maybe that is possible. Yeah. But
Yeah.
it's just time. I felt like it takes, even for this small data set, it might take a millisecond greater than the what is boosting, because it is taking a lot more things. Time is one thing, computing power, but other than that, I don't think there's any kind of limitations.
Yeah. I think adding on to that, Jatandeep asked a question is, do you think stacking would decrease model interpretability?
Yes, I think so.
Yeah, so I think that could be one of the pitfalls that,
Yep.
if you are kind of building explainable models around it, or you are kind of trying to explain it to your senior stakeholders, and then feel free to chime in, I think it would kind of, that could be one reason why people might not prefer it.
That
So, how
could.
do we solve it in that case? We use something like Shapely or like that, or how do you address it? If we have to, if interpretability is a concern.
I believe a lot of interpretability is we are able to receive from EDA. Exploratory data part is like the final result, and the glitter part is modeling, but then a lot of 80% of insights we get from EDA. You do univariate, take each column, see the distribution, do a bivariate, a column of that. I feel that time we spent there is also high, the value we get there is also high, but they're like kind of basic. What univariate, bivariate, multivariate, and then you do correlation, do it categorically, see categorical versus a numerical okay, across this category, okay, what is the percentage of salary across every job category. That itself, like it's going to go X and Y, and you have many things, and you will gain insights from it. So those insights usually match with our models. But between models, I feel it's like whatever gives a better um, accuracy, or like F1, or what we want to see, that is like the model is doing well. I won't really go too much into the how the technicality, like what things are taken, but yeah, that is what I feel. EDA gives a lot more insights, and the final results are good with models. Yeah, we can explain it.
Adding on to what Mudit asked, right, I think one other powerful algorithm that we all have is decision trees,
Mm-hmm.
which, you can start with that. And if you can kind of explain through that random forest and
Mm.
others can be explained very beautifully visually through multiple decision trees. So that could be another method that you can use. But obviously, if you have to do stacking and you cannot kind of, again, it's kind of a choice between interpretability versus accuracy. Our
Mm.
financial firms, I'm sure, would choose interpretability. But yeah, that's just how the industry works, kind of thing.
Okay. And let's say when somebody is using decision trees, along with it, can we use boosting? Can be done with decision trees. Can stacking also be done with it?
Yes,
And if
yes, we can do. It doesn't
Yeah,
matter.
that's
I
okay,
think
actually,
in the example I used random forest as, and random forest like group of trees, decision trees. So
hmm.
yeah.
Okay. Okay, fair enough. And generally in AI challenges, because that is one of the areas where a lot of people start learning from. So let's say we see a classification or regression problem, and we see there are a set of weak learners there. So can we decide to just try our hands on any of these three techniques that you mentioned, or how do we decide whether it is something that we should consider in the first place or not? It's a random question. I would love to know. Yeah, your thoughts on it.
sorry, could you say it again? I think I
So in a particular challenge that we have, okay, how do we decide, like for example, if we see there are multiple weak learners in a particular use case, how do we decide if we actually end up we should end up applying any of these three techniques? How do we take that call in the beginning, in the first step
if you
itself?
see a group of weak learners, I would say boosting. Boosting is like, okay, I- overall with lot of even Kaggle competitions, boosting is what wins mostly,
Yeah.
XGBoost and all that. So when you feel it's something as a weak learner, just I would say try. I would personally give first preference to boosting, and then bagging, but then stacking.
Yeah.
Is how I would say. Boosting usually wins everything. Decision tree and random forest, as Supreet said, it gives me an idea to take a look at the tree, decision tree majorly. Okay, how it is happening? Does it make sense with EDA? But then I would go for decision tree, random forest. They're good, and then boosting is something I would give it like the topmost
Yeah.
priority.
Any specific reason for it, where you mentioned that that first of all boosting and then bagging and then stacking can be prioritized? So
So
what is the logic behind it?
Um, see, boosting is going to reduce your, as it's see, if you see, it's like weak, taking all the weak learners and making a strong learner. So the bias goes down, and the overfitting problem goes down, and
Hmm.
you have a lot more models to work on, like different models, and they go sequentially. So it is all not like specific to your training set. So if a different set is going to come, the performance is still going to be good. But bagging, it takes a subset, so it is also good, but it is not going to, it might miss few things here and there.
Hmm.
So boosting from the Kaggle competitions I've seen, and some of the other kind of competitions, boosting, the winning person usually would have used a boosting technique. That's something
Okay.
I've seen quite common. They aim to reduce. That's why I say bagging aims to reduce variance, but boosting is less bias, and less bias, less overfitting, we get a better model.
Okay. And is there a use case where we can say stacking is where we have to start off with, or it is usually boosting that you usually start off with?
It's always boosting, because in stacking you anyway need some other algorithm,
Mm.
the trained one, to be put in the level zero. So you start with the decision. I start with the decision tree followed by boosting, and then stacking.
Okay. Yeah. Supreet, you have any question that you want to put across? I don't have any. If-
No, same. I don't have any either. Yeah, I think we can
Okay.
conclude the
So I think,
session if there are no more
yeah, I think
questions.
it's a wrap in that case for today's session. But thanks a ton, Janani, for
Yeah.
being with us today and answering questions. Even I had a set of absolutely basic level questions. I'm pretty sure about it, but thank you for being patient enough about while answering it. And yeah, thanks to participants who have been asking these questions. I think one thing that I can say about this particular session that is going to happen for sure is you'll see more of DeFi and Databuzz coming together. Next week itself, we have another session coming up, which is around responsible AI, which is kind of a very upcoming topic out here. I'll drop a link for that as well in the comment section. So do check that out. And as promised in the beginning, I'll also drop the link for our Discord and the link to join Databuzz. So I'll be doing that. But yeah, Supreet, do you have any comments to make? And Janani, of course. Yeah.
Yeah, no, thank you, Jenny. I think this was really great. I personally learned a lot. I didn't know about stacking. I have been only using Ensemble learning methods. So for me also it was a good wake up call. So I'm sure it benefited all of the users, and thank you for taking out time, especially if you're joining from US on a Saturday morning, from India on a Saturday evening. So thank you everyone for being here with us. And thank you, Jenny, for taking out the time, for putting in the effort to make the slides, to make the code. And I'm sure it will benefit everyone. Is it possible, Janani, if you don't mind, to kind of circulate this or this material?
Yeah, I can share the. Yep, I can share it.
Okay, awesome. I think that will be good. Um,
Yeah.
yeah, Mudit, I think if we can kind of spread the word,
Yeah, probably you can
that
also
will be
upload it
nice.
on your GitHub maybe or share its link. We'll just circulate it among all the people who have registered for this session.
Yeah.
I'll drop an email to
Mm.
everyone. Okay, I'll also add it in the comment section for anyone to see it. Not in the description, sorry. So you can see it from there itself. Okay.
Yes, yes.
Thank you so much. We'll see you soon
Thank
next
you.
week.
Yes.
Thank you. Bye.
Thank
Thank
you,
you.
everyone.
Take care.
Thank you.
Bye.
Bye.